Morning everyone. I'm currently an application engineer from Beacon Product Limited. We are one of the retailers for SolidWorks and the suite of products. Now in this today's webinar, we are going to see the potential of SolidWorks Premium, how we can accelerate our design and production using the SolidWorks design solution. Now, in SolidWorks, we have three suite of products. We have the SolidWorks Standard, SolidWorks Professional, and SolidWorks Premium. So now in this webinar, we are going to concentrate more on SolidWorks Premium products, where we have simulation, where we have motion analysis, where we have routing, we have counter 3D, and we have soil analysis and circuitry. So motion analysis is where how exactly assembly behaves in real time environment. And simulation is where you solve your own kind of method problems. You can solve your own linear static problems in SolidWorks simulation. And routing, you can do all cycles, frames, and PLC routing, and cycle law of frames. And if you are into reverse engineering, you have a testing on the 3D. And to do the pattern analysis, we have the analysis. And we have the CircuitWorks system. The engineering so we'll go and start into the presentation. We'll go into the motion analysis. So how exactly this motion analysis is? We have seen how we can build the model and see how the model works. But what about the function and how it behaves? And what we have to ensure that it meets all our design goals. So how exactly we do the motion analysis? Here we can see in motion analysis we can see dynamically. We'll switch over to the SolidWorks window and see exactly how the motion analysis will work. Now this is almost the assembly. This is almost the assembly, which is used in RSP operation for the car door opening during the accident. So here we have a scenario. This is just like a scenario, real-time scenario. We have two flashings over here. Basically open this. It has to sustain a load of 20,000 newtons. So let's go and look how the motion study will work. So in the motion study, we have to make sure that I have to click on motion analysis. I have to make sure that I have to click on motion analysis, and in motion study in real time I can give the motors. In here I can give a rotary motor or a linear actuator. In my case it has to move in a linear manner, so I'll flip the direction. I don't want it should not open in a reverse direction. I'll just flip the direction of it, and even I can give the distance. I can specify the distance. The range of motion I want is of 60 mm. I'll just give click on OK. Next thing I want to do is this Hall motor spreader has to sustain a load of 20,000 newton. So I'll go and select on this space. I'll just flip the direction and I'll give 20,000 newton. I'll give OK. I want to do on this similar to on this face also. I'll give 20,000 newton. I'll just hit OK and close this. Now I have defined the boundary conditions. The next most important thing I want to do is I have to group this. I have to group this as a clampings as a one, and I have to group this Hall motor spreader pins as a one. So I'll go and group these bodies. In selections, I'll group these two as one body, and the clampings as one group. And in here I can define the material, which is the type of material.
that I want to select, and if there is any friction, you can you can give input what is the friction that it may go under, and also if I want to override the material property, even I can override the material property. I'll increase the stiffness, and I'll change the damping to 10,000. Now once this contact is given, the next thing I want to do is I have to just go and hit on the click on the calculate. It will take some time, and it will calculate and give out the results. It may take some time. So already have run a motion study. So I'll just go and show you and play it how exactly it behaves. So I'll just play this, and you can see that the jaws, how exactly it is opening. This is something which you do in your testing room. You need to manufacture the complete assembly. Then you have to create a real-time scenario. This is what you exactly do in your testing labs. So you can exactly create a scenario in SolidWorks Premium. And you can exactly create, and also you can reduce the prototypes. This is where the SolidWorks Premium and motion analysis will help you. And not only that, what is the force required to actuate the motor? So even you can calculate what is the force that is required to actuate. In here I have graphs. So I'll just go and select what is the force required to actuate these clamps. So I'll go and select the motor force, and I'll select a piston actuation. Next is I am concerned in X direction, so I'll select X component. So I'll just click on OK. Now you can see that I'm having a graph. So at which position, not only I'm getting the graph, but also at which position the force required is maximum. I can even calculate that also. You can see that whenever I change my cursor position in my graph, it will show where exactly my jaws are. The SolidWorks motion analysis is not only restricted here, but also you can run a simulation over here. Now you can create a simulation even on different parts. You can create a simulation over here. If you're concentrating on this part, you are concerned more about this part in here. I have selected, so you can even run only run simulation on this. So it is simulation is integrated with motion analysis also. I have already run one simulation on this arm. I'll just show that result. Now on the screen you can see that on this arm you're able to see the simulation results. You can see that only on this arm you are able to see the results. And the advantage of this is when I move the cursor, you can see on the one measures result, this will also get updated, and you can see dynamically at which position what is the stress value I am getting exactly. And not only that, you can even calculate what is the deformation, at which position the deformation is more. So you can more concentrate on the design, and you can simulate, and also you can calculate the factor of safety of the part, and exactly what is the strength that even you can calculate motion analysis simulation on the pins as well to calculate where exactly what strength is it. So now this is about motion analysis. Next we'll move on to simulation. So where exactly our simulation will help us? Simulation where you can do all your linear static problems, and as you know, in industry when you design it, so ultimately you have to send it out to the market. So you don't know how many days it will work. So you need to be sure, like it should not fail within the period of warranty period. For this purpose, you need to do a linear static simulation. The best thing is SolidWorks is providing in SolidWorks Premium You can even work static simulation on parts as well as assemblies, and also you can work with the solid elements, and we have shell elements and beam elements, and also you can provide bolt pins and springs as well. Now we have I'll create one scenario. We have an example. This is a knuckle kit. So this is a knuckle kit. I'm going to create a study now. I'm going to create a simulation study. This is just an example. So this will be supported. This eye will be supported to hydraulics, and this will be supported to the boom assembly. So I'll just go and start a new study simulation where you can do all your linear static problems. I can give the simulation study name as well. I'll just give OK. Now you can see that now it has created a new window. The best advantages of SolidWorks simulation is the SolidWorks simulation sits on the SolidWorks. So the advantage is you can work simultaneously on the both. If you change anything in the model, that will update in the simulation. So how exactly it will help, we'll go through it and see how exactly it works. So I need to apply the boundary conditions. I need to do the pre-processor for doing the simulation. This is not any rocket science. Any engineer can do this. I'll go and add a fixture. I'll just fix these two in all degrees of freedom, and I'll give this as a roller and slider. I'll give OK. Now I have defined boundary conditions. I have given the fixtures. The next thing I want to do is I have to give and go and give the loads. So on this, all the load is acting for 18,000 Newton. So I'll give the force of 18,000 Newton. And next thing I can do is I can even apply the mesh control. I can, if any part is critical where I can find the mesh, so I can even control the mesh controls. And also I can globally change the value of mesh. I'll give it as a 10 mm, that is a minimum size that I want, and I'll hit OK. It will run in like few minutes, few seconds. It will soon finish the mesh and also give away the results. Now it will take a few seconds of time to create a mesh. It will create a mesh. You can see that this is an assembly. In no time it will create a complete mesh throughout this assembly model. Now you can see that the mesh is created. The next thing I have to do is I want to run this study. I want to see where exactly my stress is more, whether it will come in my yield stress or not. So in no time I am available with the stress results, and even I can plot the factor of safety, as this is assembly with the different type of materials. So I want to have a factor of safety plot as well. So and also you can see what is the minimum. So you are having 1.8 as a minimum factor of safety. So this is how you can run your simulation. And also suppose say if you make any modification, there is some design change that has taken place. So you need not go start over again and creating the model. Just dynamically you can edit the part. I'll give this as a 30, and also I can even change the fret size also dynamically. I'll resize this. I'll give OK. And one more thing you can observe in here, when I move to this static study 2, you can observe that I have made some changes in my design. So it is all integrated inside the simulation, where you can see that I need not again start giving the boundary conditions in here. So all the boundary conditions are intact. So only thing is I need to click on run this study. It will again run, it will mesh, it will automatically whatever parameters previously given, it will mesh and it will run the study. So this is how you can validate your design. This is for engineers to validate your design, how exactly it behaves in a real-time environment. I'll just close this, and next we'll move on to the routing. So routing, this is best suited product for oil and gas industries, and also if you're into electrical wire harnessing, and if you have the P and ID drawings, you can import it easily in SolidWorks, and you can do the tube routing as well. Let's go into the SolidWorks window and see how exactly the routing works. So now we are into the SolidWorks window. This is a heat exchanger. Now you can see that there's a heat exchanger in front of me. There are some piping piping spools I have to create. So you can see that those piping spools are missing. As you all know, reuse of the design will save tremendous amount of time. I have created my own design library. As per your company standards, you can create your own design library as well. So I need to, starting the route, I need to add a flanges. So I have some different configure, different size or different type of flanges that I have created in library. So I'll just drag and drop. I'll just drag and drop the flanges. I'll drop the welded neck flange. Okay. Now, when I place over that, the SolidWorks Smart Mate will make my work easy, and also it will suggest me which size has to be given. When I click on this size, it is telling me this tells me this is a 4-inch pipe. When I click OK, it tells me this is a 4-inch pipe that has to be placed on this motor, and not only that, even in that base configuration also you can change as you can see on the left side, you can even change the configurations as well. Now once this is done, I'll click on OK. Now the SolidWorks routing will take me into the 3D environment. It will start, I can just start manipulating my sketch, how I want the routing should be. I can do it manually as well. Now you can see that when I add a line, you can see that it has automatically filleted. So I need not think of how much radius. So all this can be defined while starting your design. So I want to connect this pipe to this flange over here. So I'll reuse my design library. I'll just drag and drop, and again it has suggested me a pipe size. I'll click on OK. Now it has started routing. I can just like the SolidWorks, I can even give the relations. So just by coinciding those 2 points, I have coincided the pipe. So you can see that how easy is to to create a start routing. So here also there is one pipe missing. So I want to connect this from this flange to here. So how will I do that exactly? So I'll split this line into 2, and I'll reuse my design, and I'll just drag and drop the flange over here, and again it will suggest me the pipe size. Now it has suggested me this is a 3-inch pipe. So I'll just go and select. Now how exactly you will connect a 3-inch pipe into a 4-inch pipe? Now this is a question which arises, and before that we'll see the capability of auto route. So if I just select the 2 points over here, now it will suggest me what is the shortest distance that has to be given. And if you're not satisfied with this, you can see that there is some interference. I can even select the alternate path here. You can see there is an alternate path in the left side. I can even change the route paths, which is the shortest one. Now this seems to be fine for me. I'll just give OK. Not only that, and also you can dynamically also make changes and give the dimensions. Now you can see that a pop-up message has come. missing elbow. It also tells if you have done any mistakes. So this is not exactly in real time scenario, this is not exactly possible, where you cannot fit a 3-inch pipe into the 4-inch pipe. So it is telling me, the SolidWorks is suggesting that you have to add a reducer to from it has to reduce from 4-inch to 3-inch. So I'll just drag it over here on this point. Again, now it has given out on that pipe size, it has given out the 4 by 4 into 3-inch. So this is the configuration which I am looking into. So I'll just click on OK. And suppose if you want to add any walls in between. So again, only thing I have to do is I have to split this route, and I have some of the walls that are available in my design library. I'll just drag on this point, and with the help of SmartMate, I'll group this. So my spool is complete now. Now one more thing you can observe, that when I started creating this spool assembly, the SolidWorks has created a sub-assembly of this complete spool. How exactly this will help? And also you can see that it has grouped in different folders. The components it has grouped in different folders. The route parts it has grouped in different folders. So while generating the bill of materials, this will help a lot. I'll open this the pipe spool. Now you can see that all these components are grouped in one folder, and all these routing files have been grouped in one folder. How exactly this will help? I'll start creating drawing out of it. Again, with the SolidWorks, all my standard views will be created in my view palette on the right hand side. Okay, and as you know, no assembly is complete without a bill of materials. I'll generate a bill of material. Now you can observe that in bill of material, I'm available with all my pipe lengths. So I need not again with the help of measuring tool, I did not measure what is the length of pipe. So in bill of material, all the pipe length also will be generated. So I'll just close this assembly. And next we have is electrical wire harnessing, where you can do the harnessing of electrical components. If you're working on electromechanical projects, this is where this electrical harnessing will help you. So we'll go and look onto this. So this is a circuit board which we have. Again, with the help of my design library, I have created my own design library, even for electrical as well, and I have a few connectors. So I'll start creating the routing of the electrical. I'll just go and drag and place it. Now you can see that with the help of SmartMate, it has mated over the place near the fan. And also you can change what is the type you need, whether you need a harness or a cable or wire, or what is that OD. You can even overwrite the OD as well. So now once I click OK, it will start the routing again. You'll be having the routing. And next is we have I'll add some more connectors. I'll add some more connectors, and there's some female connector also missing here. This is where I want to connect those male connectors to here. So I'll just drag over here. Again, it will SmartMate, and again the route will start. I want one more female connector over here. I'll just drag and drop. Again, it has created. Now next thing, what I want to do, I want to see what is the capability of auto route. I need to select only the two components. It will start creating routing. it will start create routing. I have to change the bend radius. Bend radius is okay. Oh, this was orthogonal. It has to be unchecked. Now we'll go for the auto route. I'll select these two. Now you can see that it has given me the shortest distance that is possible. Next thing I want to do is there is an interference, as you can see that it has gone into the power box. So this should not happen, right? So I'll add a wire clip so that it will move in that direction. Again, the smart mate will show me the which is the mate that has to be given. It will suggest I want to add one more clipping here. Now with the help of reroute, I'll just select this plane and just select on this. You can see that how easy it is to reroute as well. So you can exactly where and where component has to be placed and how exactly you are routing. Now I'll select this. So next is I want to add I don't want to add another routing, so I want to club in this only. So in my edit wires, I can have all the standard types of wires available here. I'll select which type of wire I want and click OK. Before that, with the help of auto route, I can guide. You can see here how easily I can guide, and also I can split here. And with the help of auto route, I can merge those wires. And next thing is I have to add a wires. So I have, as I said, I have the standard wires where I'll select and add the wires. And for this, I have to select a path, how exactly that wire is traveling. So this is one path, and this is the next, and this will travel to this span. So I have to for the second order, this is the path it has to travel. So I have to mention the path, how exactly the wire is traveling. Now once this is done, we'll go and see the harnessing, how exactly it is done. So you have created an Excel sheet with all the specifications. You can see that all specifications are there. There's an Excel sheet. Now you can see that in the drop down all the specifications of different configurations are there. So I'll go and import that in the electrical routing. I'll re-import. Now in here I can just you need not create all the parts in the design library as well. You can just give the link to the Excel sheet. That is the Excel sheet which I shown you previously. I'll click on OK. Now the SolidWorks pop-up that there are components to be added. Shall I insert or not? So I'll just click on OK. Now with the help of again the SmartMate, I'll just go and place some of the components. You can see that in here there are some components that has to be placed in this assembly. So I'll just start placing these connectors. And I'll connect the J4 connector as well. And the next is J5 connector. I'll place these connectors, and one more connector I want to place in the. Now once these connectors are placed, next thing is it will show me the harnessing. It will automatically guide me the harnessing. Now you can see that I can with the help of guidelines I can select these all these wires and merge into one. Now you can see that this kind of routing is possible in SolidWorks, and this is very easy to work and also time saving. Okay, next we have is scan to 3D. Like if you are working in reverse engineering, scan to 3D is a best suited tool for you, where you can, this is a time saving, and also if you have already the product with you, you can scan it and create a solid model out of it. Okay, there are four steps that has to be followed in this. First, you have to create a point clouds. You have to scan the complete model, you have to create a point clouds, then you have to mesh it, then after that you have to create a surface with the help of surface wizard, then finally you have to give a thickness to it and create a solid. We'll go and see how exactly it works. We'll go into the SolidWorks window. Before that, I'll just close this. I'll open a file. Okay, I'll just go and open a file. Now, if you have the scan to 3D, you'll be available with two opening files, that is mesh files and point clouds. Now I have the point cloud file. I'll just click on this and open this file. Now you can see that you have the mesh file with all the point clouds in it, and with the top surface uneven. Now you can see that the top surface is uneven. The scan to 3D, you have to follow two steps. First is you already have the scanned copy. The first is you have to create a mesh prep wizard. So which is the model that I have to create. I'll just select on this model, and next is you have to orient it. So where the origin should be. So you can give it automatically, let the SolidWorks select, or else you can even give the reference, or else you can even give the numeric input. I want it to be at the center, minus 40 mm. And also if there is any noise in the while doing the scanning, if there is any noise, so you can even reduce the noise in here. And next is while fixing into the scanning machine, you'll be fixing it with the fixtures. So to remove that fixtures, even you can select on some regions, some of the point clouds, and also you can move this point cloud dynamically in 3D as well, and you can delete some of the points. So now in this point cloud data which I have, there is no fixtures, so I'll move on to the next. I'll not delete anything. And also, what is the target point size? How many points are there in this point cloud? So you can also restrict to how many point clouds you want. You can even do that as well. You can restrict the target point cloud. Now it has started the process of creating mesh. Now with the help of these point clouds, it is started to mesh. It will take a few seconds of time to mesh the complete model, and you will be able to see a 3D model out of it. Now you can see that it has completed a mesh out of it. And also global, you can increase or decrease the smoothness as well. Over a region also you can increase or decrease the smoothness. Now the meshing part is complete. The next thing I want to do is the surface wizard. I'll just go and click on the surface wizard. I want to do the create a surface out of it. With the help of this mesh, I want to create a surface. There are two methods where it will create the surface by automatic creation, and also you can guide how exactly you want the surface also. So there are two methods. So I'll go with the guided creation. And if your model is having a symmetry, so you can select a plane, you can symmetry, and you can split the model as well, and later on you can mirror it. So this is also option. This model is not symmetry, so I'll uncheck that. Now I'll go to the next, and in the next step it will automatically paint the face identification. with all different faces, it will give out in a different color. And you can see that it is showing, I'll increase the sensitivity. You can see that all the faces will be in different color. It is identifying the faces. Basically, it is identifying the faces to extract all the faces to create a surface. Now I'll click on, there are 6 faces it has extracted and it has created a surface. Next thing is it will tell me like your model is complete. The model has come to the complete. With the help of some of the surface toolings, with the trim and all unwanted surface, I'll delete it. So I'll not carry out the step I have created already. I have gone through that step, and this is how exactly the final model you'll get. So creating this, it will take a huge amount of time. So if this is a simple model, it is a complex model, so you can create it very soon. And this is a great tool, I can tell. And next is we have toll analyst. The toll analyst basically helps to do stack up analysis in a vital mechanical fit and function. With toll analyst, these tasks can be completed directly on your models inside the SolidWorks Premium. Toll analyst is a tolerance analysis to study the effects of tolerance in the assembly. So basically I'll take and also you can see the worst case scenario, and also you can dynamically change the tolerance, and also you can update it. And the best and I'll take an example. Like if you take like when you manufacture any part, it will be not having exact size. There will be always plus tolerance, minus tolerance will be there. So if you take an assembly where you have manufactured all the parts, if all the parts will go in plus tolerance or minus tolerance, your assembly will not fit fine, and also it will not function according to your how you want it to, how exactly it has to be functioned. I'll just open a sheet metal cutter. This is a sheet metal cutter assembly. So I want to in between this I'll be passing a sheet metal where it has to be cut. So the tolerance will play a very important role. I have to maintain some gap between this upper blade and lower blade. So if that gap is not maintained, so what happens is the cutting, the function will not happen properly. So for doing that, I can inside the assembly, all the components will play a very important role. So I have to carry out the 4 important steps in toll analyst. So first, which is the major part. So I have to maintain 0.1 mm gap. Now the next is assembly sequence. How exactly I am assembling this assembly. So first is I'll assemble the lower knife block. The next is I'll be assembling the lower blade and the 2 pins that I have. I'll be assembling this, and the next will be I'll be assembling these 2 bushings, and after that and also one thing you can observe, this is in a shaded view. So when I select that, it turns out into a solid part, and for the visual purpose, it will also help you which part you are working on. So next thing is I'll select the upper blade, and also this toll analyst will give a message in green color. So you have selected all the components. You can move on to the next step. The next step is I have to give the relation. Which relation is important? In this, I'm concerned about the mate of horizontal in x-axis. So I'll just select this plane, and next is guided pin. In here, the concentricity is very important. So I'll select the concentricity. I'll do the same for second pin as well. Now in the bushing, there is outer diameter and inner diameter. So the inner diameter will be connecting to the pin. So this is important for me. So I'll select the inner diameter of the pin. And similarly I'll do for the second bushing as well. And next is I have the inner diameter of the pin and outer diameter of the bushing, and as well as inner diameter of the bushing. So I'll select In this, the inner diameter of the bushing, which is critical for me. Similar way I'll do for this also. And next is the upper blade. So it is the blade mount face. This mate is critical for me, so I'll select this. Now once this is done, I'll go to the next step. So it will calculate the tolerance, and quickly it will give me what is the nominal value and what is the minimum that is going, and minimum maximum, and also it will give out the RSS value, that is a root sum square value, minimum and maximum as well. And not only that, which dimension is contributing more, and it will give out in a percentage. You can see that this dimension is contributing more to the assembly. It is almost 72%. Like if you want to change anything in tolerance, you need not start creating all over again, start giving the GDNTs. You can dynamically just change the tolerance over here, and only thing you have to do is just hit on recalculate. In no time it will give out the results. You can see that there is a change in results. And one more thing, best part is even you can export Excel sheet. The whatever tolerance analysis you did, you can even export a spreadsheet where all the information, which dimension is contributing, how much percentage, all this information will come. So a tool analyst is essential tool to ensure that the components of your assembly always fit together and meet the mechanical performance requirements. So this is where the tool analyst will help you. And next is we have CircuitWorks. The CircuitWorks is basically to create a bridge between electrical engineering department and mechanical engineering department. Suppose say if you're working on an electromechanical component, so something you are designing. So integrating the two department will increase your design life decrease your design life cycle, and also it is more productive. And also you can import all your IDF drawings and also .emn extension files also. So I'll just go and open .emn file. Now this is the file. This is the circuit board which has been given from electrical engineer. He has designed. This is the drawing which has been presented by him. So I am having all the data, like how many layers are there in this, and also how many non-plated holes are there. You can see that it has grouped everything. How many non-plated holes are there? How many plated holes are there? This is where you'll be giving copper plating, and also it will be having each and description of each and every part. When you just go and click on the properties, it will be having each and every part thickness, what is the part number of it. So all details it will be having. The next thing I want to do is I have to just go and click on this build model. So I have it will say, take some time to build the model. I have already built that model. So I'll just open it. I'll just open that cell phone design. Now you can see that with few clicks I'm able to create a complete 3D model out of that circuit board. So how exactly this works? Whatever I have designed, where exactly it will help is in designing a casing. You want to design an enclosure on this. So how exactly you will start? You need not take a dimension of each and every circuit board, and you cannot do that. So on this you can right away start over creating a design, and also you can do the analysis where you can do the thermal analysis, because each and every electronic component will be generating some heat flux. So you can even do the thermal analysis, and also you can do the flow analysis as well. Where exactly you have to place, if it is an electronic component, where exactly you have to place the fan, etc. So you can do the flow analysis as well, and also this will also help for the sales as well. When you go for the market, this will help you in the sales as well. So this is where the CircuitWorks will help us to design. Uh, Thank you. We are at the end of this webinar. Thanks for your time. Like if you have any questions, please do ping us. Whatever questions you have, please do ping us on the chat window that you have on the screen. Somebody has came up with a question like they have missed motion analysis. So we'll send them a link where it is a webinar is recorded where they can uh, they can go over the webinar, look into it. Somebody has asked a question in CircuitWorks, how to see a layers of board. Is there any settings for it? Like what exactly what layers you want to see? So question is not so clear. Like if you can ping us again. Somebody asked, will you send us a video for future reference? Yes, we'll send you the video reference for your reference purpose. And also someone has asked, can you show us a demo in your premises? Yes, please do ping us. You can mail us. So we'll come to your premises and we'll showcase the presentation. We'll give a demo. My contact details are on the screen. You can contact me, like if you have any further queries, you can contact me on this email ID, and also I have my mobile number as well, so you can contact me. Thanks for your time, everyone. Have a good day ahead. Thank you.